Uh-huh. Good evening, ladies and gentlemen. My topic tonight will be a discussion on electronics. The the title of the topic is the comparison between analog and digital circuits. Okay, as an example, I opened the surge protector outlet with a USB terminal. Okay, this is the surge protector. These are the components. These are the components to prevent spike. That's why we call it a surge protector or spike protector. It's a variable capacitors connected in parallel with line number 1 and line number 2 coming from the utility line. So if ever there is a spike, the spike will be absorbed by this, and instead of destroying this whole circuit here and anything that's plugged in here, it will not. It will be protected by these spike protectors. So spike protectors are actually very important to us. These are the two terminals coming from the utility line, and the bottom portion is the digital circuit for processing a USB charge. This is where we plug in our cell phones. Okay? Okay, I will try to point out the difference between analog and digital circuits. In digital circuits, the components are too minute. You see those ones? It's too minute. The flat ones with the color browns and blacks, maybe those are different components. It could be resistors and capacitors maybe, which are surface mounted SMS technology, surface mounted technology, SMT technology. So if ever some of these components are burned out, okay, you cannot see it by the human eye. So obviously for digital circuit, if this whole board is had gone wrong, and you cannot troubleshoot it because the components are too small to replace, the only way to remedy this one is a total board replacement. But under the analog circuits before, the components are bigger. I will give you an example. Like this one here. Like this one here. This is an electrolytic capacitor. Okay? So if this component is to be troubleshooted, we could do it because it's big. Right? These are all analog catalytic capacitors. Okay? In the old circuit under analog, we could easily replace these ones because we got the multi-testers and how to determine if they are shorted or maybe the charges are gone. Okay, we could do it. But for the small ones under digital, we could not do anything about it. So actually, the total remedy for digital circuit is a total board replacement. Before, under analog, this is how big resistors are. Okay? And from this, we got a color code. So actually, the troubleshooting for this is that we use our human eye. If it's blackened, it might get, it has been burned maybe. So to test this if it is good or not, you just use your multimeter using the so-called resistance test. If you put the ohmmeter on the terminals and it doesn't show anything, for sure the resistor is open circuited and you must have to replace that one. Your only problem now is what is the value of the resistor. So it's your guess. Actually, as a troubleshooter, I have been trying to remedy this one by using a potentiometer like that, something like a variable resistor. If I don't know the value, I will start with the setting highest value, then I will try to rotate. Then when the circuit uh, powers up, meaning the good condition will come out as I rotate it, that will be the correct value for the resistor. Okay? So there's no trial and error. You just rotate it, and if the picture comes out later on or other things, it become normal, that's the correct value of the resistor. That's one way of troubleshooting resistor. Because if the color code has been burned and you cannot identify it, you do not know the value of the resistor. Not unless you have the schematic diagram. But nowadays, the schematic diagrams for small gadgets, we don't have the schematic for the small gadgets. For the big televisions before, we got the schematic. But now, all TVs now are actually digital. Actually, it's hard to take or will get a schematic diagrams for those, not unless you are a technician in which you subscribe for the monthly schematic for that one, so you could buy it. Okay? So guys, that's the difference between analog and digital. Under digital, the components are too small to troubleshoot. So if there is a problem, the best remedy for it is to replace the total board. But under analog before, if the components are big, okay, we could check it physically, okay, then we could replace it. So actually, analog is easier to troubleshoot than digital. But on the other hand, digital is also easy to troubleshoot because like in the computer, the computer is actually subdivided to so many boards, like the audio board, video board, microprocessor board, memory board. So actually, if there is any problem with any of those boards, you don't have to troubleshoot it. Just get the specification of the board, okay, buy it online, then plug it out. So as soon as your replacement will come out, plug it in, and that's it. You don't have to troubleshoot anything to the component level. Unlike before, we are troubleshooting analog circuit to the component level, piece by piece. But now, we can't do anything about it. The troubleshooting is actually to buy a replacement board, then insert the new one, and that's it. Okay? Okay guys, that's my topic for tonight. The difference between a digital circuit and analog circuit, and how each one is being troubleshooted the correct way. Digital circuits, total board replacement. Okay? Remove the defective board, buy a new one, then place it, and that's it. But for analog circuits, okay, if you could troubleshoot it because the components are big, okay, just do it using your knowledge of troubleshooting. Okay, soldering, using your multi-testers, it's all yours. Okay? The only problem is, in one gadget, don't assume that there is only one problem. It could be 1, 2, 3, it depends. Okay? So, electronic troubleshooting is actually complicated. Okay guys, at least I have now explained to you the difference between digital and analog circuit and how to troubleshoot each other. So, this is David De Los Reyes. Okay? Good night.